Hello everyone. Today we'll be learning about OSI model, OSI, which is uh, which is a short form for Open System Interconnection. So basically, what is OSI model? So the OSI model is an open system interconnection model. It is a conceptual framework developed by the International Organization of Standardization, which is known as ISO, in 1984. It breaks down the complex process of how data moves across the network into a 7 distinct manageable layer. Right. So each layer has a specific job and communicates directly with the layer immediately above and below it. And the question arises, why was this even made in the first place, right? So why was it developed? So like in early days, the computer was like a wild west, right? There were different companies building their own proprietary networking hardware and software protocols. There was an IBM, there was another company that a software company or a hardware company. So they made a computer, they made a network, they made a computer, they made a network, a device like a switch from a different vendor. Like if you use a different vendor networking device, right, it wouldn't understand the data structure of that existing software. So server, right? Network were completely isolated island, so they couldn't exist in that ecosystem. So then the OSI came into a play. So they developed an open standard so that the hardware and software from any manufacturer could interoperate seamlessly. Right. The ISO developed the OSI model, which is known as open system interconnection model, to act as a common language. So it was basically a standard for different manufacturer. So the data would be interacted with any of the vendor. So basically to make a vendor neutral, right? So why do we need OSI model? Like, even though the modern internet actually runs on slightly different, it especially uses a TCP/IP model, right? The OSI model still remains the gold standard framework taught globally for several critical reasons. So one of them is advanced troubleshooting, right? When the network link breaks, right, the OSI model lets engineer isolate the failure instantly, right? If the internet drops, you don't blindly guess what's wrong. We start with the layer 1, which is a physical layer. So then we think, if the internet cable plugged in, are the link lights blinking? If the hardware is fine, we move to our network layer, which is layer 3. Like, can I ping the router IP address, right? The structured approach save hour of aimless guesswork. And if that's not the issue, we move to our layer 7, which is an application layer, right? So this is why we use OSI model, and we still learn OSI model, and which is important. Another is standardization of hardware and software developer. It sets clear boundaries. If a software engineer is writing a web browser application, right, it operates at layer 7, which is an application layer. Obviously, they only need to focus on how the app interacts with the user. They don't have to write a custom code explanation how electrical signal, right, pulses through the fiber optical cable. Right, they don't have to worry about this. All they can work with the abstraction and only worry about how the browser interacts with the user. So basically it improves the efficiency, and that is how it saves times and everything. So this is why we use OSI model to this day, right? So this is an OSI layer model. Okay, so this is OSI model layer. This is a physical, this is our lowest level physical layer. Second is data link layer. Third is network layer. Fourth is transport layer. Fifth is session layer. Sixth is presentation layer. And seventh, which is our topmost layer, which is application layer. So this each layer has its own PDU. Okay, so it has its own PDU, which is protocol data unit. Okay, so yeah, PDU is here. So in our application, in our physical layer, our PDU is bits. In our data link layer, our PDU protocol data unit is frames. Network, it is a packets. Transport, it is a segment. Session is data. Presentation is data, and application is data. So PDU is a protocol unit data. So which protocol it is used? So basically it changes. So it changes name depending on the layer of OSI model, especially. So this is our OSI model. So let's cover some of the layer in this today in this video. Okay, so first is our physical layer. So this is our lowest layer. It deals with the actual physical transmission of data over a physical medium such as a wire, like a copper wire, optical fiber, or a wireless radio waves, right? It defines the hardware characteristics and electrical optical specification of the transmission medium, which is a voltage or data rates, etc. So example of this layer is hub, repeater, modem, cable. So these are basically the example of the physical OSI physical layer. It deals with the mechanical and electrical specification of the interface and transmission medium. It converts the digital analog bits into an electrical signal of optical signals. So it deals with the mechanical and electrical significance of the interface and transmission medium. What it does is it converts the digital analog bits into a electrical signal or optical signal. So it activates, maintains, and deactivates the physical connection, and data encoding is also done in this layer. So the PDU is bits, we already know that. This is the function of our physical layer. Okay, so the first function is our bit synchronization. The physical layer provides the synchronization of the bits by providing a clock. Okay, the clock controls the sender and the receiver, thus providing a synchronization at the bit level. So basically is bit synchronization is done in is a function that is done in our physical layer. Next is bit control layer. The physical layer also defines the transmission rate, the number of bits sent per second. Another is physical topology. Physical layer specifies how the different device nodes are arranged in a device, like boss, star, or mesh topology, right? So basically the cables or how the network is structured. Okay. Another is transmission mode. Physical layer also defines how the data flow between the two connected devices. The various transmission mode possible are simplex, half duplex, full duplex. So basically these are the functions of our physical layer. Next layer is our data link layer. So data link layer is it is responsible for node-to-node delivery of a message, right? The main function of this layer is to make sure that data transfer is error-free from one node to another over the physical layer. So when a packet arrives in a network, right? It is responsibility of a data link layer to transmit it to the host using its MAC address. So what is MAC address? It is a media access control. Okay, by using media access control address, we transmit the packet to our host with the help within our data link layer. So the data link layer is divided into two sub layers, which is logical link layer and media access control, right? So the MAC sub layer is responsible for data encapsulation and accessing media. Okay, we'll discuss that later on. So the PDU, protocol data unit of data link layer, is frame. So logical link control layer. So what is logical link? It is responsible for transferring the packet of a network layer to the network layer of the receiver that is receiving, right? It identifies the address of a network layer protocol from the header. So what does this mean is the frame may contain IPv4 or IPv6 packet or an ARP, which is ARP message. These all are the protocol, or you can say protocol in used in network layer or IP. So we'll discuss that in our network layer. So these all are layer 3 protocol, right? So a logic link control layer, it reads a field in the frame header. Right, and that says, hey, what is inside this frame? So it's basically IPv4 or this is IPv6 or ARP. That's how the receiving message or the receiving machine knows which layer 3 protocol to hand the data off to. Without this, the machine wouldn't know whether to interrupt the payload as internet protocol or ARP, etc. So it basically does this. It has a huge role, right? Logic link control layer has a huge role. Another is it also controls the flow control. So it manages the pace of data between a sender and a receiver, right? So So making sure the fast sender doesn't overwhelm the slow receiver. So it maintains the it provides the control flow or maintains the control flow. So another is media access control layer. So a media access control layer is a link between a logic link control layer and a physical layer of our OSI model, right? It is used for transferring the packet over the network. So what we know is this media access control layer is basically used for encapsulation and access control, right? So encapsulation, right, the IP is received by our network layer. Okay, so when you receive an IP layer, so this is the packet. Okay, so this is the packet, and here with the help of MAC we use encapsulation. So we add header and trailer in our packet, in our bit. So what header content is, it contains a MAC address of a sender or a receiver. So and this is a trailer, so it contains a 4-bit of error checking data used to detect error in received Ethernet frame. So it's basically used for that. So function of a data link layer is framing. So what is framing? Framing is the function of a data link layer. It provides a way for a sender to transmit a set of a bit that are meaningful to the receiver. So what it does is it provides a way for a sender to transmit a set of a bit that are meaningful to the receiver. Okay. This can be accomplished by attaching special bit pattern to the beginning and end of the frame. This is bit vague, so we will understand with an example. So at a physical layer, data is raw, right? It is continuous stream of a bit flowing over a wire with a bunch of binary. There is no built-in concept of like this is one message, or there is no concept of that. So what it is a raw binary or a raw data, right? So it contains 1010 or anything, right? So it contains that. So framing is how data link layer it carves that stream into a discrete meaningful chunk, so that the receiver knows, oh, this is a message. Okay, so the bit is where a message starts, right? The bit is where it ends. So without framing, the receiver has no way to know where one packet when one packet's data stop and next one beginning. So how can in order to perform framing, right, there is 3 steps. So there's basically a character or a byte stuffing, where you use a flag byte or a ESP flag. So basically you use that, and there is a bit shuffling, and there is another, so there is a fixed length of something. So if you want to learn more, I can make a separate video on framing, how framing is done. So it is a topic on its own. So another function is physical addressing. After creating frames, data link layer adds physical addresses like MAC addresses on the senders or a receiver in the header of the each frame. So basically it adds MAC address to the header of the frame. So another is error control. So the data link layer provides the mechanism of error control, in which it detects and retransmits the damage or a lost frame, as we know. And another is flow control. The data rate must be constant on the both sides, else the data may get corrupted. Thus the flow control coordinates the amount of data that can be sent before receiving an acknowledgement. So a networking device that is used in this data link layer is switch. So these are the two layer that is used in OSI model. So in this video we have covered physical layer, data link layer. So in next video we will cover our network and transport layer. So thank you all for watching. I'll see you in the next videos.